Good morning, everybody. As we are going into this Memorial Day weekend, I had mentioned that on Wednesday I wanted to cover kind of a special topic in my forecast video today on Friday, and it had a lot to do with wind. This has been a highly impactful spring with respect to wind. And in agriculture, the problems have been with too much variability in the wind, which has affected a lot of our spring field work. All right, and we could spend hours going through individual cases here, but the reality is it's been a very, very windy spring. Now, I actually don't know who made this map. It was sent to me. I have verified the data that's on it. It is consistent with an analysis of historical data from both NOAA and from what's called ERA5. That's a global reanalysis data set that's put together by the Europeans. But it's been really windy across sections of the country, whereas if you take a look here, part of the Canadian Prairie getting into the Northern Plains have not. And when this particular map came out was during a time period where we were seeing articles like this one from AccuWeather, which went out and looked at some kind of spring climatology of winds and compared this year to it. And Brian Brettschneider, this is a top-notch atmospheric scientist, climatologist. So what he's got here, looking at the data, and he said where he got it from, UCMWF's ERA5 data. This very much pans out with what we've seen so far this spring. But as I began to look into this to try to give you an explanation of what's going on here, I started to just, my mind started to wrap around something a bit different. And if you don't mind, I'd like to walk you through that here. First of all, let's do a little verification. I'm going to use what's called the Climate Reanalyzer website. This is looking at that ERA5 data. Now, when you look at the entirety of the United States, coast to coast, all right, we see that, yes, it was a very windy March this year. In fact, for those of you that were born after 1991, this is the windiest March on record. But 1991 was actually windier for the whole of the United States. But you'll notice back on Brian's map, parts of the country were not. It was the second, third windiest, and so on. But if you just come and zoom in right here on this particular section of the United States, you will find that that is definitely windier. So there's 2025, come back to 1991. In fact, you had to go back into the 70s to find time periods that were windier than this. Now, in addition to those winds, we've had a tremendous amount of severe weather winds as well. And as I mentioned, we're well over 220% of normal on our severe wind reports across the United States. In fact, we're approaching the record-setting year, which was 2011. Incidentally, also a year coming off of a La Nina winter. But just to take a look at these wind reports across the country tells you that we have two sources of our strong winds. We have the synoptic scale wind, which is the wind that's driven by the high and low pressure, and then you have our thunderstorm scale winds, which are seen here. Then just recently, a friend of mine, his name's Eric Hunt, he's out at the University of Nebraska-Lincoln. One of his interns named Mick did some study here in Nebraska looking at historical wind gusts and put together just a climatology going back to 1980, looking at different bend wind speeds and found this upward trend, as you can see here. And what we're trying to understand as we look at this is what this all means and where it's going. And is this the new state of things? Honestly, I think that's the bigger question. Is this just how it's going to be? And by the way, after I saw this, I went out and wrote just a quick script to verify the work done by Mick, and I found the same thing. I went to Omaha and plotted wind gusts from March 1 to May 20th every year from 1980 to present. This is my lifetime, by the way, and here it is. This has been a very windy spring. 2022 was also extremely windy, but remember in 2022 in Omaha, looking at wind gusts, don't forget they had that massive May derecho event that hit there as well. All right, wind. When you think about all of this, we got to come back to first principles. And I don't know if you've ever seen this, but this is a very, very just elegant way of displaying how this all works. So the sun's beaten down on the equator. Unlike what you might see on the internet, the Earth is in fact round. And as a result, all that heat, because of the orientation of Earth and its axis with respect to the sun, gathers along the equator, has to exhaust. So it goes up and north and south, creating these two large cells. Now, if the Earth didn't spin, we would have these two large wind belts, okay? But it does spin. And as a result of the spinning, we have this apparent force called the Coriolis force that shows up, and it breaks that up into multiple wind belts. Now, it's ultimately these wind belts that determine where we farm around the world. This is the very basis of what gives us our climate zones. And what's interesting is along the equator, we have air that's gathering, and it gives us one very specific region right here called the Intertropical Convergence Zone. And at any given time, this is just a look back over the last couple of days, there are always deep thunderstorms rolling in this area. Now, you're looking at the kind of the eastern Pacific, central Pacific here. There's North America and South America. But this band of deep convection that is kind of a result of all of the convergence in the low level here is kind of the birthplace of the exhaustion of heat in the atmosphere. It's how the atmosphere regulates heat. Matt mentioned it yesterday. One of those features is in the development of hurricanes, and we've got this area off the East Pacific we're watching right now, which he detailed yesterday. But I want to come back to something Matt and I show you all the time. Turns out there's a preferential area for where this occurs. So these velocity potentials, here's all you need to know. The negative values mean rising motion. The positive values mean sinking motion. This is the atmosphere breathing. And if you just kind of look at it, there's this spot on the planet where this is most efficient. And it's right here, 120 degrees east. Now, where's that? That's north of Australia. That's Indonesia, Malaysia, the Philippines, Southeast Asia, one of the wettest places globally where we have the most intense convection. And it is the source region, one of the source regions of weather systems on Earth. It's where we exhaust. This is almost near where we have that thing called the Western Pacific Warm Pool. This is bordering the Indian Ocean. This is a spot on planet Earth where it just likes to make big storms. In fact, since March, if you look at it, this has been the area. So the highest velocity potential, which remember, negative means going up, has been right here. So what we're always watching is how air comes out of this and exhausts and gets caught into the westerly wind belts. So there's one in the southern hemisphere, there's one in the northern hemisphere. And that's it. And we stir all of this up in the atmosphere by these huge areas of different land types. And what's amazing about everything I've just shared with you is it ultimately determined for us where we are going to do farming. Now, what you end up getting out of that global circulation pattern are these large areas like right in through here. These are huge subtropical high pressure areas. There's another one there. There's one down here. There's one over in Australia where we just have our global deserts. In North America, it's in our southwest. But why does it not extend here if that's geographically lined up with the Sahara Desert? Well, one of the big reasons for that has to do with topography. And if you look at it, and this map is heavily distorted, so please understand that this is not, the reprojection of Earth is giving us a very distorted view on the size, for example, of Canada or Greenland or Russia, and just so you understand, it cut off Antarctica. But I'm showing it to you because I love to be able to see the relief, and this is what's neat. If you look at the global mountains, it's really only North, Central, and South America that have a long north-south running mountain chain. If you come over to Asia and Europe, it's here. This is the mountain chains that go through. Now there's one here, right? But overall, we have this very, very different set of geographical parameters when you come over to one side of the planet here versus the other. And this is what happens. We'll call this the birthplace of our global breath, air rising. It is then transported north, after which the flow comes off the Himalayan mountains, which exert a torque on the flow. Okay, can you understand that? We have winds that are trying to go this way, and these mountains are huge, and they stir it all up, and they give us this birth of weather systems that leave and go across the Pacific Ocean. Now, come over here, they kind of come across the Pacific like that. Then they're stirred up again when they go over the top of these mountains. So there's basically flow that turns because of the way the mountain exerts a frictional force on the wind. And that gives this birth to new low pressure here that sucks on the Gulf moisture. They roll across the United States, and they leave it go across the Atlantic, and they decay as they mature, and they end up in Europe. It's amazing how the whole thing works. But it's these mountains combined with that global circulation that tell us where we're going to farm. So if you don't mind, I'll come back to it and show it to you again. The world's bread baskets are determined by these geographic climate zones established by the global winds and enhanced by topography. And it all boils down to this. And this year, I've heard from a lot of you that right in through here, it's been extremely windy. Right? And that's what we're talking about. But I want to show you something. From the breadbasket of North America to the breadbasket of Europe and Russia, these are two huge global areas where we grow a lot of food. India. Now, why India, being in the subtropics, does it have such productive agriculture? Well, it has to do with the Himalayas and the very warm water here. Every summer, this drives a circulation where we end up getting really hot in the central part of Asia, creating low pressure, while there's higher pressure over the ocean, and it drives off the top of that warm water a circulation. It's thermally direct. It's called the Indian monsoon, and we think it's going to start early this year. Over in China, there's actually a frontal boundary that lives here. It's called the Meiyu Front, on which we have the Yangtze River that sits underneath this. That Yangtze River is a topographical feature enhanced by a climatological feature called the Meiyu Front, and it rains there. But some years that Meiyu Front moves around. Some years maybe it moves a bit farther to the north, hitting what's called the the North China Plain or the Manchurian Plain, giving rise, to better moisture. When you come into the southern hemisphere, which we need to just do a whole nother video for the southern hemisphere, the subtropical arid regions are most prevalent in Australia. I mean, there's a massive desert here, so the best farming is all around the periphery. But you'd expect there to be another one here. Yet this is also a very productive agriculture region. You say, well, why? Because coming off of the westerlies, which are in this direction, there's a big mountain chain which stirs things up and allows for the building in of water here. Now, listen, this is what's neat. If these mountains and these mountains didn't exist, this would be a desert, and so would that. Like that's how it all kind of works in a nutshell. Now, we come back to the question that's been asked to me. Spring has been windy. Is this kind of like what I have to deal with from now on? Very, very windy springs. My wife, she's a nurse, an amazing woman. I'm lucky, right? She's been asking me, like, Eric, what the heck is going on? I'm so sick of these winds. So take a look at something here. We often talk in atmospheric sciences about something called zonal winds. You may hear me say zonal and meridional. Zonal means west-east. Meridional means north-south. The jet stream level is somewhere up there, around a pressure of 250 millibars, 75% of the way through the thickness of the atmosphere. We've got these really strong winds. All right, this is what's interesting. I went back to the year 2000 to 2025 and looked at every year for the months March, April, and I made a composite, okay? Then what I did was I said, well, compare this to the longer term averages. And what was very interesting was that overall, in that 25-year time period, our jet stream level winds have been much, much stronger here and here. If we're just looking at the Pacific and North America, we can look at other places around the world, but I want to focus on that. While these winds have been much, much, much weaker in terms of their zonal movement. They may be more meridional, north-south. And what's interesting about all of this to me is this. I went back then and I said, well, what about the 25-year time period that starts on 1980 and goes to 2005? And I noticed something very interesting. From 1980 to 2005, again, I just picked 25-year time periods. I can do more detailed analysis, but look, the zonal winds in here were considerably stronger, meaning they were going faster this way. And we were more meridional here, here, and there. Now, what's the point behind telling you this? Many of you that are farming right now have been farming since the 1980s. And your memory of those, what are probably I can call earlier years of your career, are probably much different from now. I mean, I'd speak at 100 different conferences a year. And I know I've listened to those, wizened farmers that talk about the 1980s specifically. And I'm going to tell you something. You were under an entirely different climatic regime at that time. And the tone was set in the North Pacific. This is how it is now, on average, and this is the way it was. And I think that's incredibly important to understand because of what that wind field is doing to our pressure patterns. Now watch. If pressure is ultimately the birthplace of wind, when you go back to the 1980 to 2005 time frame, there were deep areas of low pressure, deeper troughs that lived here and here as well. Now take a look at this. If we kind of just say, well, what have we seen since 2000? We flipped it. There's now been more regional high pressure building in that area with more lows here, giving us flow that's come over the top and kind of dove across North America like this. And part of that is being kind of shown in that longer term change in the pressure patterns across North America, giving more deeper low here and higher pressure there. And guess what happens in between? There's a stronger pressure gradient, and because of the Coriolis effect, the wind turns. And that could be a part of what this whole story is. Annual variability is high. And the causes of the spring 2025 winds have been not, I can't explain it with this broad brush view that I just gave you. But there's something particular to this year that we need to discuss. So if you look at March 2025, which is when all these articles were talking about the spring winds, take note right in through here. These are wind anomalies at 1,000 millibars. That's near the surface. Extremely windy here. But coming off the Rocky Mountains, we saw much stronger zonal winds in this particular area. That's west to east flowing winds. You can actually see it if I just show you the zonal component. So this isn't temperature. This means that the winds moving from west to east were stronger in this area. They were weaker here. You saw that earlier in the map, right? Montana, the Canadian Prairie, not as windy. They were extremely strong off the coast out in the Gulf of Alaska. The results of all of this look something like this, though. Back in March, remember how we had this long discussion in this area about the drought that was in Mexico, getting into Arizona, New Mexico, and Texas, creating all of those massive spring dust storms in this area. We were very, very concerned about that because it lasted all of March. What did we get in March? We had flow like this. We had just screaming jet stream level winds ripping over this, coming out into the plains, producing large dry slots, pushing the dry line farther and farther east. And the storms blew up farther and farther east with all of this momentum. In fact, if you don't remember it, I'm going to take you back here to March 14th, excuse me. We remember how we had this discussion? Look at that. If we keep seeing big storm clusters here and no return back into the southern plains, we are in trouble. We're in trouble for major drought development and building of drought here. And the narrative was, if this doesn't change, we're going to have some issues. That was March 14th. 1,007 reports of severe weather, 104 tornadoes. That was what the atmosphere did. And if you don't remember it, I brought along a little video. Watch this play. Storms blew up here. See all this? That is a huge dust storm that came out of parts of Texas. Do you remember this? Okay, well, what happened since then? This is what happened. We then got into the month of April. And out here in the Pacific Ocean, the jet stream winds all the way down to the surface began to accelerate in the Gulf of Alaska. And they went more across the northern tier of North America. And you see the blue here, this isn't temperature. That is anomalously slow winds. And instead of building these massive low pressure systems that raced across the country, we built massive low pressure systems that were cut off and slowly moved across the country. Do you remember a few weeks ago when all we were talking about was the big omega block? These are cut off lows in the flow that just sit there and spin, deepening their pressure, but not moving quickly, creating locally very strong wind fields. And it was this one, by the way, this was the one that was in early May, that helped make all of this incredibly wet weather down here in parts of New Mexico, parts of Texas, Oklahoma, Louisiana. Now that's just the April 21 to May 8th. Don't forget, earlier in April, we had record-setting flooding here. Meanwhile, we watched Nebraska go into drought. Parts of Iowa, northern Missouri, northern Illinois go into drought. The northwest United States, because all the flow was to the north of it, dipping deeper into drought. Even the southeast United States, up until just recently, was getting dry. Florida's been dry. And so what I'm trying to tell you here is that this has been a season of wildly varying precipitation disparity because of the way that the jet stream level winds, all the way down to the surface winds, have been so fickle. March racing out of the west. April and May cut off, slow, big lumbering systems. And I'm just going to tell you something. It's all here. Now, I wish I could just sit down and put together about an hour-long lecture for those that cared about what this is and why I stare at it all the time. Because this, going into March, that was the most critical piece. So this is the subtropics. This is the mid-latitudes. We carried out of the end of February to the beginning of March extra westward momentum. And that's what set March off on a path early of repeated high-impact systems. And then we got into April. And in April, this thing showed up. And that is a lower momentum state of the atmosphere. And when that occurred, we had the jet stream move way far to the north, and all the little cutoff lows came through. They still made strong winds, but they didn't go from Colorado to Maine in 36 hours. They went from, Texas to North Carolina in 5 days. That's low momentum. And just lately, right now, we've picked up some momentum in early May. That's why we've seen all of these, for the last, 7, 8, 9 days, multiple severe weather events. You've all seen them on the news. I don't cover the individual storm events because I don't use people's private Twitter feeds to show you stuff because I can't pay them to show that. And I think they should earn money to do it, honestly. If they're going to go out there and do that stuff, so I don't show it. I'm sorry. But you can go watch anybody else. There's always someone out there covering the high impact weather. I'm looking at these bigger picture things. Now, here's what I want to know. This is the biggest challenge. This is the top scientific challenge in weather analysis and forecasting. What does this look like when we get into June, July, August, September? And I want to know, do we have another one of these coming? And does it start here and just keep going? Because if it happens in summer, there's going to be a ridge, a big one, somewhere across the United States. There is every year. But is it going to be one that's in the plains? Is it going to be in the Intermountain West? Is it going to be east? I don't think it's going to be east, but where is it going to be? So all of this discussion about wind comes back to one very simple thing, which you saw right here. How does the air, as it exhausts from the equator, get into the flow of the atmosphere in the mid-latitudes? And is it energizing that flow, making it fast, or is it drawing back on it, creating big circumglobal ridges? And that is why we stare so much. Where did I put that thing? That's why we stare so much at, here it is, this. Okay, well, I need to think more about this because seeing the difference between the 80s and 90s and then the 2000s, I think there's a story there that we need to uncover a bit more and understand a bit more. Certainly I do. All right, where are we now? Let's actually get into a forecast. Here's the wind field right now. This got pretty low winds in this area, which is why we had a frost last night, while a deep low leaves just off the coast of the northeast. We have winds that are coming up out of the south along the Front Range here, and this is really going to affect the temperatures today. It's going to get really hot in this area. I'll show you that in a few moments. But if you're curious, over the next 15 days, these strongest winds are with the system leaving here now, and then off the coast of California, where it's almost always windy in this area. That's a geographically enhanced thing between the ocean temperatures and the land temperatures. But in the midsection of the country, to be honest, to only see this one area without, crazy strong winds everywhere is good. I mean, this is nice. Things are going to calm down a bit. If I told someone in Nebraska, hey, I think over the next 15 days, you may only see a 40-mile-an-hour gust, that is much, much weaker than where we have been. So let's take a look at where we are right now in terms of just the current weather systems. So here's the deep low last night that's just off the coast. All the cloud cover keeping everything so cool. It was the clearing out here last night that gave rise to the frost event in northern Minnesota, Wisconsin, and the UP. And then we watched another day of really deep convection down here in the south. In fact, I want to take a closer look at this because once again, just large complexes of thunderstorms erupting here. Now think about this. Because this particular spring, from April to now, has brought in a lot of wet weather into this area. And to say wet weather is the wrong term. It's been historic flooding at times. This is critical. And as I mentioned on Wednesday, the fact that this whole area has seen such repeated thunderstorms and the forecast stays wet, that later on this year, this will not be a sink in the atmosphere with dry conditions to stop Gulf moisture from getting north of this area, which means the drought situation that I think will develop this upcoming summer in North America will be highly regional, not widespread, like an 88 or a 12 or an 83 or an 80 or a 76, just to kind of toss out some historic years here. But here's where the pattern is going. There's the deep low leaving right now off the East Coast. We then watch as we get into Sunday into Monday, the pattern going back to this. Deep low here, big ridge, some feature cut off underneath it. So there's the high and there's the low, and this thing will have no reason to move fast. It'll just sit there. And we're going to show you how much rain is going to happen on the east side of this in just a few minutes. But Missouri, I hope you're watching. Oklahoma, Kansas, Arkansas, you got to pay attention to this, what's coming up. Then we get out there to next Wednesday, Thursday, Friday. Deep low settles in, but this is going to get hot in the west, very hot in the west into California. There's that tropical system Matt was talking about. Look at the cutoffs that are in the flow as well. And as we just play this on forward, boy, that's an interesting pattern to get us to the start of June. All right, now why is it interesting? I'll come back to that in just a few moments. But let's see the results of this. Right now, this morning, we do have flood watches that are out for those 4 states I just mentioned. There's your frost issue here. Take a look at why there's going to be this issue of flooding. This is the low-level wind flow right now. Or in the next couple of days. There's our very elongated subtropical high we call the Bermuda high. And it is pushing through the Caribbean, through the Bay of Campeche, into the Gulf, and right here into Texas. And if you take note of this, there is a line here where there's going to be a frontal boundary because of this large area of high pressure spinning to the north. Now, if you remember earlier in the week, I was saying all of this precipitation is just the squeeze on the atmosphere between 2 big areas of high pressure. Here they are, 1 and 2. There was not some definable deep low that's spinning across the country to create this. But where this meets right in through here, there's going to be frontogenesis, rising motion, and that's where we're expecting it to be wettest. So over the next 7 days, Oklahoma, Kansas, Missouri, Arkansas, this is the epicenter of the wettest conditions. And the possibility here of getting several inches of rain, 4, 5, 6, 7 inches is there. Now there's a broader area around it. There's better moisture for Nebraska, South Dakota out of this as well. Go to agweather.com, play the models out, and look at it. I'm not going to do it today because this video would be an hour and a half long. But you can do it and see this. But what I want to point out is if you're to the north of this, take a look at the European models. We'll come back to that in a second. There it is. The European model's 10-day forecast on precipitation anomalies. Some places here were 3, 4, 5 inches wetter than average. We're going to dry back out right into this area. And as soon as the heat comes back in, we're going to really grab some GDDs, which are needed. A lot of the Canadian prairie is drier. You can see the Northwest is drier. But we notice that this whole block of the lower Mississippi Valley, the Tennessee Valley, the Red River Valley, all the way over to the Atlantic coastal plain, the Piedmont, this whole region is showing up much wetter because of the way the jet stream is setting up with this big ridge with the cutoff underneath it still. Okay, in the near term, let's come back to this. Severe weather threat next 3 days. Take a look at it. Friday, Saturday, Sunday. Go look at these maps. They update every day. Go to spc.noaa.gov, not spc.com. spc.noaa.gov, or come to my website and find them. And then take a look. Today, Saturday, Sunday, moderate risk of excessive rain. And that animation I showed you is this weekend as to why it's going to be right in this corridor. All right, you've seen this, so let's get in and kind of get a good look at when this is going to come through. So the low leaves the northeast. Take a look. This is getting into tonight, tomorrow. That boundaries is going to be a source region right in through there of a lot of precipitation through this weekend. Just in case you're curious, this is on Sunday morning, Indy 500. Because of high pressure to the north, it just keeps shoving this rain farther and farther to the south, taking the rainfall risks, I think, out of the picture for the Indy 500. But it'll be cooler overall for this. So you've seen this, but let's go look at some probabilities. Who's dry? Next 10 days, this is the chance it's staying under a half inch. So can you see your high pressure cells now? There's the one that comes in like this. There's the one that's up here. So these are our dry regions. The west is dry climatologically. This is consistent climatologically. But if you come over here, who's wet? That's the chance of an inch. Here's the chance at 2 inches. My goodness. Here is the chance at 4. So I've got that 4-state region of Missouri, Arkansas, Oklahoma, and Kansas with better than a 90% chance, according to the European ensemble, of 4 inches of rain. And it extends over here into parts like the Boot Heel of Missouri, into western Tennessee. And these folks are hurting bad. Massive flooding early, repeated rainfall events following, and now I'm showing you a wet forecast again. All right, Where does it take us into week 2? Well, all of the models have a similar outlook for week 2, and I think that the CPC might have the best handle on this. We're drier north and we're wetter south. That's what that jet coming in like this is doing, okay? So from there, let's talk temperatures. Here's our frost risk map. You can clearly see that we are warming up across the country, much lower frost, especially with the western U.S. heat. The western U.S. heat is starting soon, but it's going to get really going into week 2. Here's today's high temperatures compared to average, getting into tomorrow. This is Sunday, and there's Memorial Day. Now, as we get into early next week, watch the west. That's Tuesday, Wednesday, Thursday. Look at the heat that's building in through here. And then you're going to see, following this, some incredibly hot conditions going into the west. I like this 5-day sliding window view of it. Here's the next 5 days. And that's day 5 through 10. That's when you need to be very aware of the high temperatures. Now, remember what I said on it last week. When you're warm here and cool there, the jet goes over the top and dives down. And that's why this region is going to be drier, will be wetter to the south. And that pattern seems to last all the way out there 15 days from now. So we just need to know, is it going to continue to do this going into the rest of June? Because that's out to June 7th. So here you go. Back to pressure. From June 4 to July 4, we see that the European model is pushing for higher than average pressure north of the Pacific high, which is centered there, and the Bermuda high higher than average pressure here. Now, the net effect of all of that pressure change is going to be resolved in the precipitation field. And this is what I want to point out to you. Now, we're going to look at this globally. You can see the model is once again drier here into the northwest. You can also see that that Mayu front is clearly farther to the south. The Yangtze River is dry. You can see that our birthplace of our biggest and baddest storms is here through the South Pacific Convergence Zone and over the Western Warm Pool. We can see a lot of Europe getting into Western Russia, getting into the Black Sea is forecast drier too. And I look at all of this and I'm trying to make sense of it. Let's just come back to our first principles. Why do I talk so much about the MJO? The MJO is attempting to capture this. Like that's what we're doing with the MJO analysis. And it seems, although signals are always weak as we approach summer, that it's going to go 4, 5, 6, 7. And what's interesting about that is that we can see that in the near term with the anomalous rising motion breaking out, doing something like this. So this over here would be phase, it's almost phase 5. Then we got 6 and 7. So it goes like that across this. And there's what could be another, what we call convectively coupled Kelvin wave. But the net effect of all of this is to do this. We're almost 150 days into the year. And if we do see that moving over toward phase 5, we tend to build a big ridge of high pressure there, while lower pressure tends to sit here. And the net effect of all of that means that we could be sliding into a June that still has these highly regional precipitation variability problems. I showed you the European model. Here's a closer look at the United States according to the GFS Extended. Now, this includes the heavy rainfall that is coming very soon into this area. You just saw that, right? But all the way out to June 26th, it's got very dry conditions to the north. And I think that this, it may not be exactly here, but I think you're going to see this all summer long. Not maybe in this particular configuration, but you're going to see the atmosphere setting up extremely wet conditions next to extremely dry conditions. And all of that is ahead of the new hurricane season, which NOAA just released yesterday. They're calling for it to have a 60% chance of being above normal. That is less aggressive than what CSU is doing. We'll talk more about that in the forecast videos next week. So I hope you found this interesting. I gave you 3 days to look at it. I am going to take Memorial Day off. It's company holiday, and I think just a nice weekend with my family would be good. I'll talk to you on Tuesday. I appreciate your attention. We'll talk soon. Thanks.